Today I want to show you the first steps to take your Shiny apps from your computer and bring them into the wild. The first step to do that is to bundle your Shiny app into a so-called Docker container. This uses a technology called Docker that allows you to wrap different kinds of software into containers that are sort of portable and can run on different machines. The idea is kind of to take your app and then ship it somewhere else where it can be served. And this is what we're going to learn today. I can tell you immediately that this will feel intimidating at first because it has a whole bunch of things that are not something data scientists are used to, but I try to guide you through every step of the way and show you the minimal amount that you need to understand to become productive. So with that said, let's dive in. To start off this video, let's start with familiar territory. Let's start with a good old Shiny app that just lives in a single app.r file, something like this here. So if I run this, because I'm right now in positron, nothing happens. But if I were to take this last Shiny app command and send it to print and then re-execute this, then you'd see that my Shiny app opens. This is a little Shiny app I let GPT generate for me because I didn't want to really worry about the app itself. Instead, I just have taken some GPT generated app and we want to take this and bring this into a Docker container. So again, this does nothing too fancy. It just generates a bit of data and then it shows a data table, an about page and a plot. And now instead of using this Shiny app command, let's leave the script as is and then let's close the app for now. And now if I source my file again, the app doesn't immediately start. So instead, let us call the Shiny run app function to call our app from this directory. And we can also say that we want to run the app that is inside of the app.r file that we currently have open. And if we do that, we see that this works and shows us obviously exactly the same thing as we had before. But there's one thing I do want to change here. Namely, I do want to use some of the arguments that this run app command has. Namely, I wanted to change the port and set it to something fixed like 3838. This is a port I want to use and it works exactly the same. The only difference is that this number here inside of my URL, it is now on this port. This means that my app currently is served at this IP address, which refers to myself. It's called localhost and it is served on a particular port that I've specified here. And what I can also do is to change the host. If I do host, I can set it to some different IP address. And here I want to use 0.0.0, which is also a common thing to do. And if I call this, you'll see that this didn't really change because the IP address is still the same. There's a tricky technical component here that resolves this generic 0000 IP to my local host here. Even though this doesn't change anything here, I'm doing this here because we'll need it inside of the Docker container later on, because this 0000 thing will be then pointed towards our computer outside of the container. Again, technical things here you don't have to worry about here, but I wanted to show you what's going on here. And as you can see from the history, here we were serving on this initial IP address on a different port. Then we've fixed the port and the IP address was this 127.0.0.1, so the local host. And then in our latest iteration, we had our 000 IP address, which in the end was resolved to this IP address anyway. But that's really the only thing we changed. And in all of these instances, my computer and my R session currently serve as the one basically dealing with the Shiny app. When a user now makes an input or just goes to the page, it is my computer, my R session that will show the user what he came to see or what he came to click on or kind of what he came to expect. And now kind of as a mental model, what we want to do is to move away from my computer and my R session to first an R session that is exclusively running inside of a different container. And if this container thing is portable, we can also move it away from my computer. And this is how then things can run on the internet on some server that is hosting my container. That's kind of the idea here. So we do want to basically call this function here but from somewhere else, so that someone else can take care of this listening on this port and then doing interactions on this Shiny app. And this is where Docker comes in. Docker is the tool that we're going to use to make this happen. And if you look into the documentation of Docker, you'll see that it is available for all kinds of Linux systems. And also if you're on a different machine, like on a different operating system like Windows or Mac OS, you could also look into Docker Desktop. Personally, I prefer to use the command line because I then have the feeling I can follow along more of like Stack Overflow posts or some other posts or other commands that I see online to get the job done that I'm trying to do. But the choice is yours of what to use. Just know that inside of this video here, we'll just use the command line and we'll just use the Docker engine as is without Docker Desktop. And if you are, for example, on Windows and want to replicate these steps, you can also use the Windows subsystem for Linux on your computer to have a Linux machine inside of your computer. And then with Positron, you could connect to this Windows machine on your computer to work from there as if you had a Linux machine. I'm skipping the details about this installation process here because there are already 1,000 tutorials on that kind of stuff. I do want to focus on this R and Shiny thing here. Just know that there is this Windows subsystem for Linux, which is written as WSL. And if you look into documentations of that, you'll find installation instructions if you are on Windows, and then you can install Docker on your subsystem. So with this installation thing out of the way, kind of skipped, let's talk about how to actually work with Docker. And for that, we can switch into the terminal, and just know here I have Docker installed on this machine. So this is why when I call Docker, it will tell me you can use all of these commands, and honestly, you don't need most of them. I will just show you the couple of things we need. And the first thing that we need is to assemble a Docker file, basically a recipe of this Docker container that we're going to build. And then we'll just say, Docker, take this recipe and build this thing so that we can ship this container. So let's create a new file. Let's call it a Docker file. And then we can fill this with instructions to use. And the first thing that we need is to have a base image that has already all of the things installed that we need. And obviously we'll need R and we'll need Shiny installed to run R Shiny inside of this container. Really think of this as its own isolated world in which we want to run things. And therefore, to run things inside of there, you'll also need to install the programs that you currently use to run things. So this means R and R Shiny need to be there. And the Docker system is built in a way that allows you to create a recipe file from different recipes that exist out there in the world already. And so what we can say is build this thing from somewhere else. And there is this Rocker project, which is called Rocker because it's a combination of R and Docker. And Rocker has different kind of images. And here the image that we want is the Shiny image, and we want to have it in its latest configuration. And if you want to find out more about this image, I'll tell you in a second what an image even is. If you need more information about this kind of base recipe that we're using here, you can look onto the Docker Hub and find that there is exactly the image we're looking for, the Rocker Shiny image. And I have a description here that links to all of the information about this project, and there is information about different kind of images that are out there. For example, you might want to have an R image, but not combined with Shiny, but with some other stuff, or with all the tidyverse packages already installed. This is where different kind of package could come in handy. For example, the Rocker Shinyverse package already sounds like it is a package that combines the Shiny with the tidyverse thing. And here you see that it's just another Docker file, which looks really intimidating if you don't know what's going on. So let's go back really quickly, but we can stick to easier to read things like here where it says the Rocker Shinyverse has already installed many R packages like the tidyverse package and so on. So basically we could also start with a different base recipe that has even more stuff installed, but here let's just go with this Shiny thing. So with that, we have already a Docker file that comes equipped with basic stuff like an Ubuntu operating system with R installed and Shiny installed. So basically it's its own little machine. But this little machine might still not have all of the specific packages installed that we need in our app. For example, we have these packages here and we want to use them as part of our app. So let's also make sure that we have ggplot2 and DT installed on this machine that is later going to execute this code here. And for that we can in our Docker file say, hey, run some R command to install the packages that we need. So let's call this docker run command and we'll run the R command, which can execute any R code. For example, if I were on my machine, we're going to call R, it will immediately start R, or I could use this RE flag to call just R code that prints hello. And you'll see that R was started and hello was printed. And then R was closed again, right? So here when I call one, it will say there's no such thing because I'm no longer inside of the R console. So here we can do the exact same thing. Say, okay, let's call some, or let's execute some command, and then let's do install packages. And in there, we'll install the packages ggplot2 and DT. And for repos argument, we can specify a URL. In our case, let's just specify the R project. Okay, so what happens inside of this recipe now is it gets this base recipe, and on top of that, it will install the necessary packages. Now it's time to get our file that we currently have on our computer into this Docker container, because this app.r file currently lives on my system, not inside of the container. So we'll try to get this in there. And for that, the Docker file allows you to run a copy command, and we can just take our app.r file and copy it to the root destination inside of the repository, not repository, but of the container. So this dot is just current working directory. It will copy this app.r file in there. And then we can run the command function. We call the R command with the E flag again. And then we can execute the shiny run app command like we did before. So we say, okay, let's run this app.r file. Let's specify a host like before. This time we're again using 0000. And then we specify that the port will be 3838. And now technically this would work, but we'd never have a way to reach this thing, the app that is then called with this run app thing, because this thing now happens inside of the container when this command is called. But we now have to make sure that my computer is able to get into the container, because by default, these containers are supposed to be encapsulated and do their own thing and don't have any idea of breaking out outside of the container, which means we also can't necessarily easily break in. And in order for us to make it possible so that my computer can actually look into the app that is being served on this container, we have to open up a door. We have to open up a port, basically. So this means that we have to expose this door or port, as it is called inside of the technical world. And so we say this port is exposed so that via this port where this app.r file, this shiny app is served, we can get out of the container. Okay, with that we have a Docker file, which is our recipe to build a so-called image. And these images can then be used to spin up the container that is configured in this way. So what we do here now in the console is to use the docker command, and now we say we want to build an image. And what we need to do there is to specify a tag, which is kind of a name, and say, okay, let's call this image my first shiny app. And the file that gives us the instructions of how to build this image is given via this F flag, and there we just say use the Docker file, and we run this thing in our current working directory. So that's why we have to use this dot here. And then you see that this is now starting to run. It is building this thing, but there is some weird glitch in the console. I kind of want to have it displayed nicely. So let me call that again. And now the console doesn't have this kind of weird glitch anymore. And now you see all of the steps that are happening to build this thing. This will take a couple of seconds, and depending on what you install, it might even take more than a couple of seconds. But the idea here is that this image now is build so that we then have an image that has all of the R and Shiny stuff and all of the packages and the exposed port and the app.r file inside of it. And then we can take this and start up this container so that we can interact with it. So that's why it takes a while to build these images, because there's a whole lot of stuff to be done. Cool, this is finished now. So we are able to run this image. And what we can do is use docker run and specify the image that we want to run. Here we say, let's do my first Shiny app. That's exactly the tag or the name that we specified up here. And now if we run this thing, you see that, nice. Now an R session started apparently inside of this container, and this Shiny run app command was also executed just like we wanted to. And it says listening on this IP address on this specific port. It's the exact same thing that we have seen earlier when we called this thing locally here, right? It says listening on here on this port. So this means now this thing seems to run inside of our container. And what we can do now is to click on this thing and see if we can actually reach it from outside of the container from my computer currently. Let's say, let's open it up in the default browser. And unfortunately, this doesn't work. That's kind of a shame. And the reason why this works is exactly related to the same reason why we had to expose our port here. We exposed the port of this container saying, okay, it can take in information on this door number 3838. But we also have to say that, okay, if we on our machine go onto this door number 3838, it should also point us towards the same door on the container. And this is where we have to specify this port matching. So instead of just calling docker run and then the image name, we also have to specify the P flag to specify ports, and then say that the 3838 port on the container will map to the exact same port on my machine. So now if I run this, the output is exactly the same because I can see what's going on inside of the container. But now if I click on this link and try to go through it with my browser, we see that, hooray, there's our app. And we are on the port and the host that we've specified here. So that's pretty cool. So now we can run some code and use this app here. And in the background, it will run this R code, and all of this happens inside of this container. So with that, you have built your first Shiny Docker container. And here I've tried to keep it as simple as possible, but that's also why we neglected a couple of things. So let me show you how to do better or differently. You see, instead of copying this app.r file directly into the root of the container, let's actually put it somewhere where this Shiny container expects it to be served. So let's copy it to /srv and then Shiny server, and then let's go there. And then instead of using this command that just runs the app from the current working directory, we're going to actually run a different command, namely /user bin as in binary, and then let's run Shiny server. This last step will start this Shiny server application inside of the container, and this Shiny server application will look inside of this directory for app.r files. And the reason why I knew that, okay, this kind of command is available on this machine is because I referred to the documentation of that and looked into what is the intended usage. I deviated from that at first because I felt like the previous route is more familiar if you haven't worked with that before, but now let's actually go the intended way. What this means is that we also have to close our current container and then build a new image. Let's call it my second Shiny app, because now we're creating a new image from this Docker file, and that's why a whole lot of stuff has to run again. This was actually pretty fast because this thing here was cached. You can see here this install packages, the thing that took a whole lot of time before, it was cached by Docker because it realized up until this line nothing changed, so I'll just run this stuff again and this part is cached. That's pretty neat. You'll have some time savings included in this. And now we can use docker run again and say, okay, let's do my second Shiny app. And here I hit tab to autocomplete, and then it always runs this, or it adds this latest tag, which we don't really need. But here you can immediately see that the output is different. And the reason why this is the case is because now we get the output of this Shiny server application, namely this thing here, and not of the R console itself that we called before. But let's see what happens if we try to refresh our page here. We still see that, nice, everything works great. It is still the same thing. We just have different things being shown inside of our console. Nice, we're making progress. I hope this doesn't feel too intimidating anymore. I try to show you every little step in between. And at the end of the day, this is just something we as modern data scientists have to learn, because it's kind of expected nowadays that data scientists can also deploy the stuff that they build. And this is why it helps to dive into these technologies. And for the same reason, I recently created a PDF guide that shows you all kinds of different stuff that we as data scientists have to learn when it comes to stuff that we build inside of the R ecoverse. So if you're interested in that, you can follow the link that is in the description to get the PDF to see what kind of our tutorials are out there that I have available for you to learn different kind of stuff, depending on what you want to learn inside of the R data science ecosystem next. And with this shameless plug out of the way, let's get back to the video, because there are more things I want to show you about Docker. You see, this copy command here isn't the only thing we can do. I mean, obviously we can do other stuff. What I meant was that we can use this copy command also to copy whole directories. And if we look into my Explorer, we see here that I have a few directories. For example, we have directory app1 and app2. And really app1 and app2 are exactly the same. The only thing that I changed was to include this version 2 name inside of the title of this Shiny app. And what we can do inside of our Docker file here is to say, let's copy this whole app1 directory into the app1 directory that is inside of the Docker container in this path. Actually, we don't need this slash here. And then we can do the exact same thing with app2. Let's do the second directory as well. So now what we can do is we can close our container and let's build our third Shiny app, or our third Shiny app container. Let's build this thing. Should be pretty quick because it still has this installation stuff cached. And now what we can do is to run this my third Shiny app container. Again, as I autocomplete this with the tab key, it will add this latest tag, but it doesn't matter at all. It still works the same. And now when I refresh this page, we see that, okay, this looks different now. This doesn't look anything like our apps. But if we read this thing, it will actually tell us that you can see an application on your server at a particular path. So what this means is that we could do app1 here inside of our URL. And then nice, there is app1 and then there is app2, which has as the only difference version 2 inside of the title. So that's pretty cool. You can serve multiple apps from the same container image. But this begs the question, do these apps then interact with one another? If one thing is running, can the other app not currently run? Well, let's try this out. And to make this work, I have created another directory called app2slow. And the only thing I did was inside of the server function where the data is created, I have created the code show notification I'm sleeping. Then I have logged something to the console. And then I have a sleep timer for 10 seconds. And then there is a notification that says I'm back, and then it logs to the console that it came back. We can run this thing by simply running it locally first to see what happens. Really, it's the same app, but with wait time, but still it helps to run this. And here it says this address is already in use. So let's use some other address, or it will also be in use. Let's do 8080. And now we can see that, okay, this is our app as before, but the output here takes longer because even on the first initial attempt, it waits 10 seconds. And then it tells us here, I'm back in this notification. And inside of the logs, we see went to sleep and came back. And if I were to rerun this thing, then we'd see that, okay, it says I'm sleeping here. This thing is recalculating. The console says went to sleep and it's still there. And now it's back. And now it says it came back. Pretty cool. I mean, not that cool, but we have some basic functionality and some basic logging. So that's nice. So with that, we can test if the slow app will stop the other app from working properly. So that's why in our Docker file, let's copy not the app2 container, but the app2 slow container, and we'll copy it to the app2 directory so that in our URL nothing changes. And then we just have to rebuild our Shiny app. Let's call it fourth Shiny app. And then we can run this thing. This started up. And now we re-execute this. We'll start at our Shiny server start page. This is app 1 and this is app 2. I've actually put them next to each other, so for a split screen. And what we can do now is to say, okay, this thing here starts a calculation now. It says I'm sleeping, this thing is busy. But as I change inputs here, we still see that the output updates, which is nice, which means that the app is kind of independent of the other app here. So that's neat and pretty helpful. But if we look into our console here, we see that we don't have our helpful logs from before, you know, these ones you see here. This is a crucial way to, or crucial instrument to help me debug a Shiny app when something goes wrong. So this is why I would like the logs to also appear. And for that, I took a look at the documentation of Shiny server, and it turns out that if you specify a specific environment variable inside of this container, then the logging will be transferred from the R console to also the console that we have here. So if we set the environment variable Shiny log standard error and set this to 1, then hopefully if we rebuild this thing, then now as we run this and then go on to the app, we see that, oh, something is happening now. On this, we see here that there is the code like attaching package DT, the following objects are masked. That's exactly the kind of output that we have when running this code locally. And if we were to go to 2, we now also see that the log of I went to sleep or just went to sleep, this I here is just an information icon. We see that this thing translates to being displayed here as well. So that's pretty nice and that's super convenient. Finally, let me show you one more technical thing that can be really tedious and freak you out when you don't know what's going on. For example, if I had a different Shiny app that requires a different package that has some tricky components that also requires different software to be installed on the computer. You might think, okay, what kind of crazy package is that? Well, for that I have another app in here that uses the SF package to run spatial calculations. It doesn't really do anything much, it just generates some circles in a plot, but still this will require the SF package, and the SF package will need different software to be installed on the computer that runs this code to work properly. It will need software like GDAL, GEOS, Proj, and honestly, I don't know what these do. I just know that they are required for SF to be installable. Thankfully, there is the pack package that allows you to figure out what are the system dependencies of any package. So if you have the pack package, you could look at the package system requirements and then specify, say, the SF package, and then it will look up stuff and it will say, you know what, with this command on an Ubuntu machine, you will be able to install all of the things that are necessary to run this thing. So what we could do is take this thing and then before we run install packages, let's run this stuff, which will run this command, and then we run this other command on the Ubuntu machine, which will install the other things. And now inside of our install packages, we are ready to use the SF package. And now what we have to do is to rebuild this thing. It will take longer again because now we have inserted stuff before this installation. So this means that this thing, line 7 in this case here, has to also be re-executed and won't be cached. So this is why it will take a while. Also line 7 changed as well. So this is also why this whole thing definitely needs to be re-executed. So this has taken a while, 330 seconds almost to install the new things because SF is such a huge dependency, but at least it worked. If this system dependencies for the SF package weren't available, then this installation would have also failed and then we would have wondered, okay, what's going on here? And in order for us to check whether everything was okay, let's copy this third app that actually uses this SF package. So let's copy app redirectory to serve Shiny server app3. And now we have to rebuild this thing, but luckily the exhausting or the hard part was probably cached, not probably, it should be cached. So therefore this went really quickly and we can run this container now. So let's do my 6th app. And now if we go to app 2, we see that this still works and is still slow, just like we wanted it to. So let's go to app 3. And now you see that inside of this app, we also have this spatial map of randomly generated points. And we could also now download GeoJSON files, but that's beside the point here. For now, let's just be happy that we can generate circles now using the SF package. The code for that actually just uses this one function from the SF package. But either way, with that, we have covered everything I wanted to show you here. I hope this wasn't too hard. Docker can feel really intimidating in the beginning, but I hope I was able to show you all the different steps that you need to create your first Docker container and also how to start it on your machine. But of course, this doesn't mean that you have this app now gone from your computer. Currently, everything still runs on our computer, but inside a container. But the nice thing about these containers is that they are portable, and so now they can run on any server. So with that, you can take the container and run it on some other server that is accessible via the internet. If you want to have a video on how to do that, let me know in the comments, and I might just do another video just like this one here. And of course, if you enjoyed this video, let me know by hitting the like button, and don't forget about the PDF guide that you can also get for free. And now with all of that said, I say thank you for watching, and I'll see you next time.